Here we have one of those absolute value inequalities. So you have to remember the rule for dealing with something like this, where you have the absolute value of some expression less than or equal to, or just less than, but here it's less than or equal to some number. The rule is that you put the expression between the negative and the positive of that number. So part of this looks just like what we have here without the absolute value bars. 2x minus 3 is less than or equal to 1. But the 2x minus 3 also has to be greater than or equal to negative 1. It has to be on the small side of positive 1, but on the big side of negative 1. So if you just write 2x minus 3 in between negative and positive 1, that's what we have to solve. So we're trying to get x by itself in the middle, so start by adding plus 3 to all three sides, and we get 2 less than or equal to 2x, less than or equal to 4. Then go from 2x to x by dividing by 2 on all three sides, and we get 1 is less than or equal to x is less than or equal to 2. So x ends up being between 1 and 2. Could be equal to 1, could be equal to 2, could be any of the numbers in between, like 1 point something. Here's what that looks like on the number line, and here's the interval, the closed interval with these square brackets. So bracket 1 comma 2 means 1 and 2 and everything in between. And the absolute value of 3x greater than 15, for this kind of a situation where we have the absolute value of some expression greater than some number, it breaks down into, okay, 3x could be greater than 15, or 3x could be less than negative 15. It's on the big side of positive 15, or it's on the small side of negative 15. Divide both sides by 3, we get x is greater than 5, or x is less than negative 5. So here's what that means. X could be any of these numbers over here greater than 5, like 6 or 7 or 10. Or x could be any of these negative numbers that are less than negative 5, like negative 6 or negative 7 or negative 10. So this is in two separate pieces. And when we write it in interval notation, it's two separate intervals from negative infinity to negative 5, together with the interval from 5 to infinity. Now, simplifying radicals. The square root of 50x squared y to the 7th. For the square root of 50, 50 is not a perfect square, but we can factor it into 25, which is a perfect square, times 2. So we can take the square root of 25, which is just 5, times the square root of 2, which isn't anything special, so we just leave that part under the square root sign, the square root of 2. The square root of x squared would be x, and the square root of y to the 7th, well, y to the 7th is not a perfect square, but we can factor it into y to the 6th power times y. So that's y times y times y times y times y times y times one more y left over. The square root of y to the 6th would be y to the 3rd, and then we've still got the square root of y. So after we pull as much as we can out from under that square root sign, we have 5xy to the 3rd times the square root of still 2y. Number 32, now this is a cube root. We're looking at the cube root of 125. Now 125 is a perfect cube. The cube root of 125 is just 5. The cube root of a cubed is just a. And the cube root of b to the 15 power is b to the 5 power. So we end up with 5a b to the 5th power. 100 to the 3/2 power. So remember what it means when you have a fractional exponent. The number on the bottom of that fraction, the denominator, tells you what kind of root to take, and then the numerator of the fraction tells you what power to raise that to. So here, it's the 1/2, the 2 in the denominator tells you to take the square root of 100, which is 10, and then we take that to the 3rd power. 10 times 10 times 10 is 1,000. So 100 to the 3/2 power is 1,000. Now here we have a to the negative 3/2 times b to the 1/10, all to the 5th power. And first of all, we can say this is a to the negative 3/2 times 5 times b to the 1/10 times 5 power. Negative 3 over 5 times 5 would just be negative 3, so we got a to the negative 3. B to the 1/10 times 5 would be b to the 5/10, or b to the 1/2 power. And then for our final answer, I don't want to leave it with a negative exponent, but a to the negative 3 means the same as a to the positive 3 in the denominator. So for my final answer, I will write b to the 1/2 power over a to the positive 3 power. Okay, here the directions say add or subtract if possible. Now 5 plus 3 times the square root of 7, it's not possible to add those. We can't combine them because they're not like radicals. So we have to just leave that as 5 plus 3 root 7. Number 36, the square root of 99 minus the square root of 44. Now to start with, we can simplify each one of those individually. 99 factors into 9 times 11. So the square root of 99 would be the square root of 9, which is 3, times the square root of 11, which is just the square root of 11. Meanwhile, 44 factors into 4 times 11. So the square root of 44 would be the square root of 4, which is 2, times the square root of 11. Now we can combine these because 3 root 11 minus 2 root 11 equals 1 root 11. So just 1 times the square root of 11, or just the square root of 11. Now we're multiplying. The square root of 14 times the square root of 2 would be the square root of 14 times 2. That is the square root of 28. And that can be simplified because 28 is 4 times 7. So the square root of 28 would be the square root of 4, which is 2, times the square root of 7. Number 38, the square root of 5 times, in parentheses, square root of 7 plus 4. So we're using the distributive law here, and we're taking root 5 times root 7 to get root 35, and then root 5 times 4, and the 4 and the 5 do not get multiplied because one of them is under a square root sign and the other one is not. So this just stays as the number 4 times the number square root of 5. And then x plus the square root of 7 times x minus the square root of 7. If you multiply this out, x times x is x squared. The outside and the inside cancel out. We've got a minus square root of 7x plus square root of 7x, and that just adds up to 0. And then last, we have a plus root 7 times a minus root 7. A plus times a minus is a minus, and the square root of 7 times itself, the square root of 7 squared, is just 7. So we end up with x squared minus 7. Rationalizing the denominator means that we want our final answer to have no radical sign in the denominator. The denominator should just be a whole number. The square root of 3 over the square root of 10. Right now there is a square root in the denominator. To fix that, we can take this denominator and multiply it by another square root of 10 if we multiply the numerator by the same thing. So I'm multiplying the numerator and denominator both by the square root of 10. On top, square root of 3 times square root of 10 is square root of 30. On the bottom, square root of 10 times square root of 10 would be the square root of 10 squared, or just 10. So I have successfully rationalized the denominator. I have the square root of 30 over 10. Number 41, 13 over 2 plus the square root of 3. Here you got to remember the trick. When there's two things added together like this, you want to multiply by what's almost the same but with a different sign in the middle. So 2 minus the square root of 3. So if we multiply the top and the bottom by 2 minus the square root of 3, on top, 13 times 2 is 26 minus 13 times the square root of 3. On the bottom, when we multiply this out, 2 times 2 is 4. The outside and the inside cancel out. We got a minus 2 root 3 plus 2 root 3 that just adds up to 0. And then minus the square root of 3 times itself would just be 3. So 4 minus 3 is 1, and 26 minus 13 root 3 over 1 is just 26 minus 13 times the square root of 3. Number 42, in a right triangle with legs 10 centimeters and 9 centimeters, how long is the hypotenuse? Rounded to one place after the decimal point. So this calls for the Pythagorean theorem. A squared plus b squared equals c squared. The c stands for the hypotenuse, which is what we don't know. That's what we're trying to find. So I just left that as the letter c. And the a and the b stand for the legs, how long the legs are. And we do know those numbers, 10 and 9. So 10 squared plus 9 squared equals c squared. 10 squared would be 100, and 9 squared would be 81, and then 100 plus 81 would be 181. So now we have c squared equals 181, and then c would be the square root of that. We undo the squaring by taking the square root. So c would be the square root of 181, and my calculator tells me that that's approximately 13.5. So to one place after the decimal point, the answer is 13.5 centimeters. Now, perform the indicated operations and write your answer in the form a plus bi. Remember, the I stands for the square root of -1, which allows us to have square roots of negative numbers. Whenever you see the square root of a negative number, that's when I gets involved. So the square root of -81 would be 9i. The square root of positive 81 would be 9, just plain old 9. So the square root of -81 is 9i, and then 4 plus that would just be 4 plus 9i. In number 44, we are subtracting. We're taking 9 minus 8i minus 4 plus I. So 9 minus 4 is 5, and the minus 8i minus the I is minus 9i. So the answer is 5 minus 9i. And number 45, we are multiplying. So if you use the FOIL method to multiply this out, 3 times 8 is 24. On the outside, 3 times minus 3i is minus 9i. On the inside, we get plus 16i. And last, we get minus 6i squared. But whenever you see I squared, that would just be -1. So we have 24. The I terms combine into plus 7i, and then minus a 6 times a -1 would be plus 6. Then the 24 plus the 6 would be 30. So our final answer is 30 plus 7i. We're almost done. We just have a little bit more to go. So we'll wrap this up in the next video.